Greetings, I'm Blackjack Fitz, and today's puzzle is Shady Equation by The Pedaling Pianist. Let's read the rules. We've got a normal 6x6 Sudoku, so we've got to place the digits 1 through 6 in every, row, column. I got all thrown off by the 6x6 and box of the Sudoku. We're going to do Yin Yang today, so we'll shade some cells such that all shaded cells form one orthogonally connected area, as do all unshaded cells, and no 2x2 area is entirely shaded or unshaded. So let's see if we can do sort of classic looking Yin Yang. So that potentially is a way to do the Yin Yang, because all of these brick colored cells are orthogonally connected, and all of these green, hunter green cells are orthogonally connected, and there's no 2x2 that's entirely one color or the other. So that's how Yin Yang works. Counting Yin Yang, we've got a digit in a shaded cell shows how many times that digit appears in shaded cells. So that's interesting because it's only one of the two sort of colors that we're going to use. And that's the only distinction, right? It's just shade some cells and then leave the other ones unshaded. Okay. So I might actually want to use like gray and green so that I know that gray is shaded and I can keep track of that better. Anyway, quadruples. A digit in a circle must appear in the surrounding 4 cells. If a digit appears twice in a circle, it must. If a digit appears twice in a circle, it must appear twice in the surrounding 4 cells. Right. So we've got that's what's going on here. So let's look at a different one. Let's look at that. We've got to have 2 1s and 2 6s. So this is going to be all 1s and 6s here. So 1, 6, 1, and 6, sort of like that. Those will both be 1s, and those are 6s, or those are 1s and those are 6s. I'll actually just leave that in because that's a pretty solid way to start this puzzle. It's a lovely little 6x6. I'm hoping to get on with this one here. I don't know where I was going with that sentence. If you want to play the puzzle, there is a link in the video description. I would encourage you to give it a try. But now, with the help of my friends in the Twitch chat, I'm going to try to solve this puzzle. So let's go ahead and get started. Now, I did look at the comments on Logic Masters about this, and it was like very funny. It was sort of like, the way to solve this puzzle is to sort of stare at the grid and contemplate this sort of universe for a few minutes and then figure it out. So I'm going to try not to just start throwing a bunch of pencil marks in and actually think about how this works from the outset. So the first thing I'm saying is there's a lot of 3s. All of these quadruple clues, that one, this one, this one, and this one, have a 3. And that's entirely encased in those cells. So there's 4 3s in there, but there's only 4 different columns at play, and there's only 4 different rows. So none of these are 3s. Now I think that means if none of the cells that I've highlighted here in pink are 3s, where's the 3 in column 6? I love the start. How ridiculous. I don't know if this is how I meant to start, but one of these is a 3. I'm pretty sure we're going to get 2 3s in the corner, because either those both are 3s or those both are 3s. What a way to start. Okay, so that's very cool. Can I do better than that? I mean, one of those is a 3 and one of those is a 3. So this is actually 2, these are all from 2, 3, and 4. Because we've got 2 3s in there. Because the 3s that have to appear in these rows are both in there. So now that's all of the 3s in. How does that work? Oh, no, 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 that is a complete bunch of malarkey. In fact, that's definitely not true. Because this 3 in this quadruple can be the 3 in this quadruple. Yes, and if this was true, right? If there's 4 threes in these cells, then there'd have to be a 3 there, there'd have to be a 3 there, because we would need a 3 in each of these rows. And then how do you put a 3 in that quadruple clue? The answer is you can't. So this is why they said you have to contemplate things before you jump right in. So let's think about the yin yang here. Because we're going to have... I'm wondering about shading in here. How is this going to work? I think that... So, okay, this can't be all unshaded. I'm going to use green for unshaded and gray for shaded. This can't be all unshaded. It just doesn't work. So we either have a situation where one... Oh, that doesn't work either, because we could do something like this. Okay. No, I don't know. Maybe. Where we pick one off, or we do something like... I'm just thinking like... Because 1s and 6s are the extreme digits. How does that work with... Okay, at most, 1, 1 means the shadeds cannot contain multiple rows. I'm not sure I understand what that means. Okay, let's talk about yin yang broadly speaking. Because I've glossed over some important information about yin yang. So in a yin yang puzzle, this pattern is never possible. I just finished doing another yin yang puzzle on stream, so I apologize to the people that are hanging out with me very late into the evening at chat, but because it's a new video that I'm posting, I will briefly explain this once more. You can't have a checkerboard yin yang because in connecting that gray to this gray, no matter what route you take, you'll always have a green that can't get to its friend because it's been surrounded by grays. So you can never have a checkerboard. You also can't have too many different strings you can't have this sort of pattern along the perimeter of a puzzle, because no matter how you connected gray to gray this way, you've isolated this green from that green. They can never touch. And by the rules of yin yang, all of the shaded cells and all of the unshaded cells have to connect. So that's some sort of foundational yin yang logic here. And so I was trying to think about what that means, because one of these is either, I mean, it could be like this. Let's just put it in, right? It's that, or it's flipped, where the 6s are 1s and the 1s are 6s. That's how this works. And so what I'm wondering is, can you do, like, if those are shaded, then all of the 6s have to be shaded. And no more 1s can be shaded. How would you get all of the shaded? That means that you have to... That means that you have to be on every... Oh, that doesn't work. Okay, I don't think that this works. Okay, let me try to explain. First of all, if one of these sixes is shaded, they're both shaded, and you have to do this. If neither of these sixes are shaded, you have to connect, like, you still have to shade one of these because you can't have a 2 by 2. So the one will be shaded. So no matter what, we're gonna end up with a triomino, a little L triomino in this pattern here somewhere. 3 of one kind of shading and 1 of the other. And the question is the 2, and it'll always be the 2 6s in the same group, either shaded or unshaded. And the question I want to ask is, can it be shaded? And I don't think matter if you flip it around here, because the point is, if the 2 6s are shaded, then every 6 has to be shaded, and there's going to be a 6 in this row, and there's going to be a 6 in this column. So even, I guess, if we put a 6 here, we've got the 6 here, we've got the 6 there, and we've got to have a 6 in this row too. So we've got to get the 6 in this row up there, let's say. So now we're connecting all of those together. But now there's a 1 here somewhere. Somewhere there's a 1 there. I don't know where, but I'm shading another 1 to go pick up that 6. And that's impossible. So what I think I can say is, one of these 4 cells exactly is shaded, and 3 of them are unshaded. And the 1 cell that's shaded is a 1. And that means that we can't have any stretch along the perimeter that's fully shaded. That's not possible. So if we found, for example, that this was a shaded cell, because we know that, well, we would know that all of those are unshaded, I suppose, because we could never get shading over to there without doing a full row here and picking up a 1. We can't have any more 1s that are shaded, because we're gonna have 1 shaded 1 in here. Okay. What now? Right. So maybe we have to think about, can that be the unshaded loop, this triomino? Because if that's true, that's a good point. Let's do some basic Sudoku. Appreciate it, GDC. That's fair. That's a 1 and a 6, just by sort of foundational Sudoku. And that means that neither of those are on the loop, actually. Right, so no 1s or 6s anywhere else in the puzzle can be on the loop. Or it can be shaded, excuse me. We're not doing a loop puzzle. The only 1 or 6 that can be shaded is the one of the 1s in this quadruple clue. So there's a 1 and a 6 up here. I mean, it's really going to make it tough to do, like, right. So what I'm wondering is, is this possible? Because now I think all of that would have to be shaded, wouldn't it? All of this, in fact. Yeah, I don't think this is possible. Because the shaded, well, no, only those would have to be shaded. I mean, one side, this would have to come out. but it could actually be, I think like that, this is possible now that I think about it. Sort of like that kind of thing. Yeah, okay. Not quite. So I don't think I can rule this out. Ooh, okay. 1 and 6 are in these and in these. The shadeds must touch the perimeter in box 1, so the perimeter in row 6 is unshaded. Ah, that's the key. Right, that's kind of what I was getting at when I did this over here. Right. So, okay, I don't actually know that this is that true no matter what I do? What if those are the, and that's unshaded? Yeah, it is, isn't it? Because then, well, yeah, I mean, that's impossible. You can't wrap that completely. I just want to make sure that that's true no matter how I orient it. It is true though, isn't it? Like if that's green and that's shaded, there has to be a shaded up there. That's obvious. Okay. If this is green and that's green, this is the only case where I'm not positive. But yeah, I mean, this can't all be. Yeah, of course it is. Of course, I'm being daft. No matter how you do it, there's a shaded cell in the perimeter on box 1. Now, how could that get all the way to there? It can't, because it would have to take all of this, even if it just went from there, right? So these are all definitively unshaded, which means that this is a shaded cell. I guess okay. There's no 6s shaded. So we have a maximum of 15 shaded cells is the other point. Because we could have a 1. It's counting, right? That's what we're doing. Yeah, okay. Okay, we're counting them. Yes, counting Yin Yang. So because we know that 6 is not shaded, and we only have the digits 1 through 6, that means we have the maximum of 1 plus 2 plus 3 plus 4 plus 5 shaded cells, which is 15. So we've only got 15 shaded cells to work with, which is something that I hadn't appreciated until this very moment. So that's 1. We're down to 15, max, most, elsewhere. Now, we are going to need some shaded cells along here. Can this be shaded? I really don't think it can, because yeah, that can't be shaded. That one I'm comfortable with. I'm not sure about this, but this cell right here can't be shaded because this would have to connect all the way here, and this has to be, there has to be a 1 or a 6 in here, because you can't put both 1 and 6 there. So that one for sure is not, which means that one for sure is shaded. Now I don't actually know what's going on with all of those. So can you get shaded anywhere in column 6? GDC seems to think not. There is a 1 in row 1, column 4, 5, 6, which is always green. There's a 1 in row 1, column 4, 5, 6, which is always green. Yep, and a 6. So there's definitely green cells here somewhere. And you can't get shades to wrap all the way around. So yes, all of those have to be green. That is true. In fact, I think that one has to be green too, because it's actually a 1 and a 6 up here that have to be unshaded. So even if we could potentially get 1 in here, but then this would have to be a 1-6 pair. So that becomes shaded. I don't actually know that I don't actually know that these two are shaded. I know that there's some shadedness. There's something shady going on up here. Right. So, well, we've made some good progress. Yeah, I mean, we've got 1 and 6, like that. We need another green cell in here. One of these two is for sure unshaded, because we have a 1 and a 6 down here. Okay. How do we proceed? Well, we've got, oh no, I was going to count my unshaded cells. That's not how this works. Dang it. Okay. Maybe I have to think more carefully about this then. Or is it the quadruples? Are we doing something with quadruples yet? I don't know. Well, I do know that there is a 3 here and there is a 3 here. And those are separate 3s. And same is true with 4. So these aren't, that's not 3 or 4. Or 1 or 6. I think that's a 2 or a 5. These ones could be 1 or 6. Unfortunately. Let's see. And we can do similar stuff here, can't we? That's 3 and 4. That's 3 and 4. So these aren't 3 or 4. There's a 2 or a 5. Or this could be the 1-6 pair, and then that could be a 3 or a 4. Ugh, all right. Okay, but no, damn it. Okay. How do we go from here? Do I have to think more? I think I have to think more about this. Is there any sort of orientation of this I can rule out? Or is there any cell that I know must be on, for example? Presumably we're going to figure out which one of these needs to be on the loop, and that's going to do some things. What we can't do... Okay, I think maybe we can rule this out, because then we would need to do that, right? We can't, yeah, because we can't do like all of these. Oh wait, no, that's not true, because we don't have to connect. It's not a loop building exercise. Hold on. So all of those could be green like that. Yeah. No, I don't think that that is true. Sort of like this. All right, we're done. Yeah, okay. So, first, I've done so many loop puzzles lately. I just did do a yin yang, but I've done so many loop puzzles that I was thinking like you have to kind of connect around this whole thing. But you can actually have end points in a yin yang. Okay, I feel like I'm not quite. I feel like I did understand this a bit. Like I kind of got the 1s and 6s within a reasonable time frame. We've got good shading going on here. I know that there's a maximum of 15 shaded cells, which is pretty constrained. Like, that's 7 of them, and we would have to get like, something like, I don't know, that. It's like 15 exactly. So it's going to be very forced, I think. Obviously, that's how we solve the puzzle. Where are 3 and 4 in this? Well, yeah. No. I mean, this is a 1 of 2 and 5 and a 3 and 4. Hmm. 1 and 6 are down here. I'm prepared to do that. If 5 is shaded, it would put 5 in row 6, column 6. I see. I do see that. Okay. Because we've got 2 full columns of the grid, I think that that's actually going to have to be true. I don't see how we could not have 5. I might be wrong about that, but it sure feels like we're going to need more than 10 shaded cells here. In fact, I wonder if I can prove that. 1, 2, 3, 4, 5, 6, 9. I mean, in principle, you could have just 9. But no, I don't think you could, in practice, have 9 to break up all of the... 2x2s, because you need 1 in each 2x2, which is 9 exactly. But you have to cross over, right? At some point, you have to... What's that? That feels like about the minimum you could do. 1, 2, 3. Yeah, and that's like 13. So I don't think it's possible, actually, just from a count perspective, of getting there without... because, you need 1 in each 2x2 box, but you have to bridge. You have to bridge the gaps somewhere. It's just not possible. You can't do it in 10. So we do need a 5. And because we need a 5, there's probably a more logical way to do it, but I'm fine with the way that I've done it. It's its own path. Apologies to Pedaling Pianist if that's not the sort of insight I was meant to find. But I do think that that's fair. We need a 5. So we need shaded 5s. But the 5 that's shaded in row 6, or the 5 in row 6 is unshaded, and the 5 in column 6 is unshaded. But we can only have 1 5 across all of these cells. Therefore, that has to be a 5. I feel great about that deduction. I feel fantastic about it. Now what does that mean? That means that the 5 in this row has to be shaded, and the 5... Does that mean that this can't be 5? Okay, there's a 5 here. That's a good point. Which means that this is a 2, 3, 4, 5. And these aren't 5. So it's 2, 3, or 4. So These are from 2, 3, 4. Lol, lol, lol. Okay, so I'm wondering if this can be 5, because then we would need at least that many shaded cells along the perimeter. And it feels like that's using up a lot around the edge here. We do have a few bonus ones, because when I was testing it, it felt like 13 was about the minimum shaded cells I needed. So I've got a few spare, shaded cells I could work with. But if that's 5, we've got to get to the shaded 5 that's in row 1. So a minimum of that many would be on the sort of thing. And then if we did our sort of best to connect these as, I don't know, that doesn't seem right. Like this, as efficiently as possible. That's not even possible. I don't think that's the way to think about it. 5 is in row 3, 4, column 1. Row 3, 4, column 1. Yeah, there's a 5 there. So we do actually have to connect around, because there's a 5 in one of those. Which means that the 5 that's shaded here and the 5 that's shaded there, a minimum of those have to be all shaded. Which means that's unshaded. Aha. Oh, actually, that's not right. Because this 5 rules it out of those in the box, which makes it there in the box, which means it's in there in this box, which makes this a 2, 3, 4, 5. These ones aren't 5. Now, right, yes, so if the 5s were those 2, that would work. Now, what does that mean for this? That does mean, no, those could all, no, that doesn't work. This can't be the, oh, no, I'm being silly. Okay. It does mean that is, no, it doesn't, does it? It could be like that. Ugh, okay. What do I know then? So, okay, all the 5s are shaded 2, 2. Like, the other side's less powerful. The 1 helped. The 1 helped a lot, but the 2s, I don't think. What about 4s then? There's an unshaded 4 here and an unshaded 4 here, which means that all the other 4s have to be shaded. Right. All of the other 4s have to be shaded. 5 in box 4. Yeah, there's a 5 here. Okay. I'm sorry I don't do regular Sudoku. I'm very sorry about that, GDC. I refuse to just follow the logic all the way through. But I appreciate that you're here to force my hand and walk me down the path that says you must do some Sudoku. This now isn't 3, 4. I darn near just flat out refuse to do it. Okay. So, right. The 4 in here has to be shaded. I don't know about the 3 though. This is now shaded. That doesn't necessarily have to be the 5. Okay, let's just keep doing Sudoku before you yelled at. This is a 3, 4. Okay, I want to do as much Sudoku as I can, and then we'll think about it. This is 2, 5. This is 1, 6, and a 3 or a 4. Charcuterie. So 1, 6, and a 3 or a 4. That's a 5 and a 2, 3, 4. Okay. I think that this is 2, 3, or 4 because it can't be 1, 6, or 5. So that's a 2, 3, or 4. I'll pencil mark that. This now is 1, 6, 3 or 4. Okay, this is the 3 and the 4 on this have to be there, so that's 3, 4. Now this is 1, 6, which means that isn't 1, 6, which means that is a 1, 6. Along with that, we can get rid of both of those. Now all of the 1s and 6s have to be like this. This is a 2, 3, 4. And this is there's a 2 in there. So this should very clearly not have been marked with a 2 when we had a 2 there. But that's 3, 4. This is a 2 and a 1 or a 6. 2, 3 quad in the middle needs a 2. Thank you kindly. We'll make that here. These aren't 2, neither is that. Now, we need a 3 here, which gives us a 4, 3, 4, not 2, which gives us a 2 here. Now, what am I missing? 3 and 4 look up, give me a 5 here. 3 and 4 look over and give me a 2. That's not 2. 3, 4, okay. That's a 5. 5s are always shaded. I didn't think I would stop to do that, but I will, happily. Right. So, have I done as far as I can go with Sudoku until I figure out the shading? Don't want GDC to get mad at me. Okay, I've got that quad's done. 2, 3, and 4 is done. 1, this is a 1. We need a 1 on that quad. So I can do more. One, 6. Okay, so this is the 3, 4, and a 1. We've got 2 and 3, 4, and then 2 and 3. So I think the rest has to do with how we resolve the shading. 1s can never be shaded, so this has to get out that way. And we have 2 green 4s already, 1 and 2, so all of the 4s have to be shaded. Thank you. Don't know which of these is the 4, I don't think. Now, we've got, do we have any shaded 2s yet? I don't know. How about 3s? 1, 2 shaded 3s. So if that went around that way, then how, oh, okay. Something like that. Actually, no? Like that? That, no? Yeah, that could be the shading. That might work. All right. Okay. One of these is a shaded 2. That is true. And one of these has to be the shaded 5. So we've got one of our shaded 2s. Oh, sorry. Just standard yin yang stuff here. Apologies. Avoided 2x2. Avoided checkerboard. Avoided 2x2. Okay. Sorry. I'm sorry, Stu. I'm sorry. I saved your puzzle till very late. Right. And take. Okay. Is it about 3s? I've got. Oh, that's our 2 shaded 2s. Unshaded. Shade, which gives us a 1 and a 1. 6 and 6. These both become unshaded. Now avoid a 2 by 2. That can't be another 2. So that's 5, 2, 2, 5. That becomes unshaded. And that becomes shaded for connectivity. And now we need to count our 3s and 4s. We've got 1 shaded 4, 2 shaded 4s. Oh wait, okay, so 1 shaded 3, 2 shaded 3s, 3 shaded 3s. That can't be a 3. So that's 4, 3, 4, 3, 4, 4, 3, and that's 3 in the corner. Very nice. Oh, I feel like I didn't I didn't totally grasp that in the way that would have done it justice. I appreciate the support, GDC, as always. I hope you guys enjoyed that puzzle. It's very beautiful. I actually am kind of impressed. I'm pleased with how I did with the sort of opening, I think what is meant to be the opening logic around 1s and 6s, and thinking about what that meant for the sort of perimeter. I kind of got that, and then I kind of muffed up the middle part a little bit. But we got there in the end, and I had a good time doing it. I hope you did too. That's the end of the video. See you tomorrow. Until then, don't forget to follow. Please. No, but yeah, that'd be cool. Anyway, take care. Cheers. Bye.